Hello again. So today we're going to have an interesting little puzzle for you. And it comes in the form of an algebraic proof. And by the end of this proof, I'm going to prove to you that 2 equals 0. Okay? I know it sounds ridiculous, and that's because it is. So your objective is to find the error in my proof and explain per se why this proof is not valid to prove that 2 equals 0. Now, we saw there's another video on our channel, you may or may not have seen it, that proves that 1 is equal to -1. That involves imaginary numbers. So some of our Algebra 1 students or geometry students who haven't learned imaginary numbers may not quite understand that yet, but this one is going to involve only basic algebra. So let's take a look. The first thing I'm going to do is create a simple let statement, and I'm going to let x equal 1. That's a perfectly standard let statement. I'm basically assigning a value to a variable for the purposes of this problem. Okay. And now I'm going to perform some basic algebraic steps. And the first thing I'm going to do here is square both sides. Remember, we can do whatever we want to an equation, as long as we do it to both sides. So I'm going to go ahead and square both sides. Okay. We can definitely say that if x is equal to 1, well, x squared is also equal to 1. All I've done is square the left and the right side of the equation. So nothing wrong with that. Now what I'm going to do here is subtract 1 from both sides of the equation. What we get is x squared minus 1 is equal to 0. Okay. And now we can factor x squared minus 1 using difference of perfect squares. So difference of perfect squares states that if x squared minus y squared is factored, it's x minus y times x plus y. We can validate that by multiplying it out, either using FOIL or the box method, whichever you prefer, or double distribution, the most technically correct of them all. So here we get x squared minus xy plus xy minus y squared. These two numbers add to 0, and we're left with x squared minus y squared. So this is just proof that this works. So then we could say that x squared minus 1 is x minus 1, x plus 1. Okay, because the square root of 1 is 1. We just follow the formula here. And again, if you were to multiply this back out, you would get x squared minus x plus x minus 1, which does validate our factoring. So we have x minus 1 times x plus 1 is equal to 0. So all I've done here is just factor the left side. Now, the next step I'm going to perform here is divide both sides by x minus 1. And again, all I'm doing is dividing by the same thing, both sides of my algebraic equations. And that will produce x plus 1 is 0 divided by x minus 1. Now, we know that 0 divided by anything is just 0. So at this point, we can go ahead and replace the x with a 1 because that was our initial statement that allowed me to create this equation in the first place. And what I've got here is 2 is equal to 0. I propose to you a challenge, and that is to find the flaw in this proof. We obviously know that 2 does not equal 0, so there must be something wrong with one of my steps. If you can find it, post it in the comments and share this video with some of your friends. Let's see if they can get it.